All right, sorry then. Whereas, thanks for listening, Barrage. Right. So the problem is how do we integrate this? The way we integrate functions like this, Shaq, is Shaq, have we get now when I game look up now? The integral of 1 on x is ln x. You all remember ln x from what is ln? Log to the base e, right? Okay. So whenever you integrate 1 on x, you'll get ln x. But in a more general case, if you had to integrate f prime x over f of x with respect to x, the integral of this is always going to be ln f of x. What are these signs again? Modulus. Why do I put modulus? Right, you can't find log of a negative value, right? So that's why we always put in modulus signs. You okay with that? So once the numerator is the differential of the denominator, we could use ln f of x. Are you okay with that? Like in our example here, what's the differential of x? 1. Okay? So the numerator is the differential of the denominator. So, Kalina, since you're here, right? What do you think will be the integral of this? Please remember to sign up for the task courses, right? Huh? I'm sure the name. Sure? Yeah, I'm here. What would this be? Kalina, any guess? Yes, I think I see your name already. I think I see your name already. Didn't feel good, okay? Yeah, Kalina, what we can do? Right? Is there any way I can make this look like this? Yeah. Move it 2 outside. Very good, Yash. Right? Yash said that I can move it 2 outside. And what's the integral of this? Ln. So that'll be 2 ln mod x plus c. Can I do anything else? I can't bring it 2 here. Yeah, could, right? If I want to, right? But I want to. Do I need to put in mod sign here? Or the square? Come sharp today, boy. Everybody okay with that? Right? Try this, please. Think about what will the integral of number 2 be? Ready? Victoria, to finish. Then copy it down and let's find the integral of this. Figure out what the numerator should be, right? Yeah, we go separate. We can have separate. You all ready? Super. Up. Any answers? Samika? Chuck? You got you? Where you got? That's it? Right? Why would I make this? Why would I make this work out earlier? If the numerator was what? It would have been easy. If I wanted to make this easy, the numerator should be what? 1. What's the differential of this? 6x, right? So if the numerator was 6x, and we know what the answer is? If the differential of the denominator, the numerator, then it's just simply ln of the denominator, right? Right? So if that was it, the answer is what? Ln mod of, hence, right? But the 6 wasn't there. So what do I do? Right? Here's what, well, not multiply by 6, but if the 6 was here, I just multiply by 1 on 6. And I'll cancel and give back the original thing. So here is 1 on 6. Sorry? What is the rule? The rule is, right? If the numerator is the differential of the denominator, then the integral is ln, right? So the problem was that 6 was missing. So if you put the 6 here, you have to multiply by 1 on 6. That's okay? David? You sure? Right, just one more. And let's take a look at tricks. Online, are you okay with that? No, I just put in this 6 so you will see that. Huh? Right, it was missing. So if you're writing a 6 here, yeah, you gotta divide it out. So you get back the original thing. Try this one, not the best example, but try it. Yeah, you can factor that. Hmm? Yeah, and then cancel it. You do that. No, if it's simplified by ln, you should get the same. Understood? Oh, you took one last one. Wait one. Wait one. Right, Sarah. Oh, Sarah sent me good job, Sarah. Right, Darian, what I got for this one? 1 on 10 ln 5x squared plus 10x. Anybody try something else? But okay with this? Yeah. So there's something else that we could have done. Could we have factored out 5x? Could we have factored out 5x and you'll get x plus 2? All right, now that would. I thought it would have canceled off. All right, now that wouldn't. Right? So you would recognize that for this to work perfectly, 5x squared will be 10x when you differentiate, and here will be 10. So if I multiply by 10, I have to divide by 10. That's the one. That's okay? Right. So I wanted to remember that. Just a quick question. What is the inverse of ln again? You can move ln across. If you have something like this. Right, e to the power. All right. Right, I'll show you something later on. You'll need that, right? All right. So we did these integrals. We didn't do integral trigs at all. So I just want to review that quickly. Okay. What's the integral of sine x? The integral of sine x is what? Minus cos x plus c. What's the integral of cos x? Sine x plus c. What's the integral of oh, that's a nice one. I can't give all that else now. What's the integral of sec squared? The integral of sec squared is tan x. Might have a nice one here for them. But what's the integral of this? One on? That's something very wrong. The hint I want to give you is to use what you learned here. Work it out. Try that fast a minute. Right? Integrate tan x using what I showed you there with ln. Try it quick. Tan is what again, Keshav? Tan is what again? Sine over cos. So really and truly you're integrating sine x over cos x. Try that fast. Right. Come on, very good. You actually been watching my TikTok videos. All right. What's that? Yeah, that's just. So what is here? Right. What's the differential of cost? The differential cost is minus sign, right? So if I put a minus sign here, minus sign must come here. Right? So the rule is minus ln cos x plus c. Y'all see enough? What's the differential of cos? Minus sign, right? So it will be ln cos x, and you must have a minus sign outside here. If I put a minus here, I must put a minus here. So cancel that off. Right, but some people said sec is the answer. Why? Some people said that the answer could be ln sec as well. Yeah, that's also correct.
1 over cos x is, yeah.
Right. You can take this minus 1 and put it here. Cos x to the minus 1. And that will give you ln sec x plus c. Okay? There's some rules for you to remember. Right, so just some quick rules for you to remember, right? Suppose I ask you now to integrate cos 5x squared with respect to x. What will that be?
Yeah.
It will be 1 over the differential of 5x squared, which is 10x by the integral of what? By the integral of cos, which is sine. Right? That's a shortcut. But was it a long way to do it? Can we do this? Let u equal to 5x squared. Right? And you'll get du dx is 10x. So you will get dx is equal to du over 10x. That's okay? Right? And then when you substitute, you'll get the integral of cos 5x squared is u dot du over 10x. But we have a slight problem. Problem is what? What's the problem then? This should be in. Everything here should be in what? In u. Right? Ideally, everything here should be in u. So what you could do here is solve for what? Solve for x. Right? Well, in this example, we can kind of treat it as constant. I just want to revise this way. Yeah, and something wrong with it. Try this one for a minute. Try number 2 there. Will you forget his phone? Oh, yeah. Oh, yeah, try that fast. Right now, what we got here? 1 over the differential of 5x plus 1, that's 5 by the integral of sine is minus cos 5x plus 1 plus c. Yeah. Ideally, no, that's why I skipped that example. I want to show you a different way to do it. Right? This one here to work out nicer. So here, if we let u equal to 5x plus 1, so see this one here, actually, ideally, I should use a trig identity to simplify it. Right? Ideally. So du dx is 5 and dx is equal to d1 5. Right? So when you substitute, you'll get the integral of sine u dot du1 5. We can take this 5, bring it out here. Right? What's the integral of sine u? Minus cos u. Right? And then you'll end up with minus 1/5 cos, go back what u was. 5x plus 1. That's okay? So the one I was showing you before, I'm gonna show you the way you're supposed to do that, right? Well done. So Jaydan, how are we doing number 3? How are we doing number 3? I didn't really give you a rule for number 3 as yet, right? So how you would integrate number 3? Maki. Jaydan, what you want to do here? Very good. So Jaydan said that you remember this, right? You remember that cos 2x is equal to cos squared x minus 1.
Really?
Remember that? Right? And then Jaydan said that cos squared x is really what? A half cos 2x plus a half. Carry across the 1 and divide everything by 2. Carry across the 1 and divide everything by 2. Right? So all we have to do now is this. Instead of integrating this, we're going to integrate a half cos 2x plus a half with respect to x. It's a little bit easier.
No.
No, no. I lost you. All right, I'm gonna start over. Here's what Jaden was saying, right? Jaden was saying now that we can't integrate this just like this. So instead of doing this, you have to use an identity that will simplify it to something like this. Right? So the identity that Jaden chose was cos 2x. Cos 2x is 2 cos squared x minus 1. Move across the minus 1, you get plus 1, divide everything by 2, and you get it. So now I'm taking off this, right? And I'm putting this. Right? Pardon me? Ma'am, the minus 1 went here, ma'am.
You can do
And
the
the-
steps. Break it down.
Okay, all right.
Yeah.
Right? I'll do a video like that, right? So, or I will see that. Right? Are you okay with that? Yeah? So I went from here to here. Now, can we integrate this? Watch this. And we can integrate a half. A half is just a half x, right? What's the integral of this? The integral of cos 2x is what? The integral of cos is?
1/2.
So it's 1 over the differential of this by the integral of cos, which is sine. And that give you a lot of stuff earlier, right? So the integral of cos is sine, and it's 1 over the differential of 2x, which is 2. Right? But don't forget the half on the outside, right, Faith? And then when you multiply this out, oh, watch this all here. Watch this here, right? Although I'm doing 2 integrals, right? Already?
Yeah, we ready.
Although I'm doing 2 integrals, right? Remember, I'll have a k here and a next k here, right? 2 different constants. So when I add up 2 constants, I'll get 1 big constant. That's okay? So there is no need to write 2 k's, just write 1
I
constant.
see. So, like, you know, no, not substitution, but the last thing in integration is when you separately divide the x into 2, and you have.
Yeah. And you have 1 constant. Yeah.
Yeah.
So you'll end up with 1 over 4 sine 2x plus a half x plus c. That's okay?
Yeah.
Well, remember this is not much?
Yeah, right.
Online, any questions? Hello, okay, online. Isaac, Isaiah.
That's what I'm. Yeah, sure.
All right, let's go. Copy that up. Try number 4 and 5. Online, I know it's a little hard to send the answers, right? But just learn it and not follow it. 1, 2, 1. I did it for him. Oh, yeah. Oh, yeah. Did you solve? Oh, yeah. For those who don't remember the identity, right? For those who do not remember the identity, sine squared x is equal to, well, sorry, I'm going to put it this way for you. Cos 2x is equal to 1 minus 2 sine squared x. Tomorrow, that correct? Sarah, like Sarah, sending everything. Okay, so when you make sine squared the subject of the formula, or you can make 2 sine squared subject of the formula, it's up to you, right? You will end up with a half minus a half cos 2x. Sorry. That's okay? Selena, you got it? When you make sine squared the subject. Yeah. Right? I just move this across here and I move this here and then divide everything by 2. Yeah. Right? Because anytime you see this squared, you have to use identities. So you're going to get the integral. You can put the 4 on the outside of 1/2 minus a half cos 2x dot dx. Multiply everything by 4 if you want, so you'll get 2 minus 2 cos 2x dot dx. And then work out the integral. Well, what's the integral of 2? The integral of 2x. What's the integral of 2 cos 2x? That'll be 2 by a half sine 2x plus c. So your final answer is 2x minus sine 2x plus c. ¿Dónde quedó? Pick up. Tell me where. So you follow how I get this, right? Right. So I plug it in here. That's not right. I'll plug it in here. Right? And then I multiply everything by 4. Then I integrate. The integral of 2x. The integral of 2 cos 2x is 2 by 1 over the differential of 2x, which is 2. And the integral of cos is sine. I'll go back. Yeah, that's that. What's up? Yeah. You with this thing again. Yeah, I'll bring this here and if one remain and divide by 2. What are we doing here though? Vishana. Oh, what are we doing here? They have a sine to the 5 and a cos. What to do? Okay, that's well, why do we use the sine 5? Not analytics for that really, right? There is one, but long, right? Anybody seen something else? Just go and say that's now.
So that 5 is supposed to be there?
This 5? Yeah. A little lower. Anybody online have any answers? I'll give you a hint. It's a different technique you have to apply. All right, let me make it easier for you, right? I'll make it a little easier for you. Hopefully. Huh? Am I here? No, you can't add 1 to the power and calculate that with sine. Sine function no work like that. Something else you can do with a bracket, right? What else you can do? Anybody online? Huh? Sophia, we were saying that?
So what if it integrate sine actually
Take all his sine. Another option and then break it up. Some easier than that. Okay, and then replace what is sine squared. All right, but something easier than that. Yeah, use substitution. Right? We could use substitution and what you would let u equal to sine n. When? Okay, all right, I will say you say that, all right? Finish it, man. Finish it. Use substitution and work it out. Okay? All right. Yes, sir. Well, hopefully. You say so it should work. That's an option, but that will take a little bit longer. Right? Because you will still have a sine next to there. Yeah. Beyond number is a problem. Oh, yeah, try it fast, make it substitution, work it out. Okay, sharp, hurry up now. Right, somebody. Fresh. Cover. Parmesan. If I did what? Parametric differentiation. We didn't want to in one example. I thought we could get more than Sunday for from 9 to 6. Huh? No, it's up to one. Let's just stay until 5. Yeah. What about to meet? I come to teach all there, no? I come to teach all there. All right, y'all done? Yeah. What? Sunday is no online. Sunday is in person only.
Hey, but I said Sunday already. Yeah, I want this sheet. I can get from that.
All right, so watch here. So du dx is equal the differential of sine x cos x. Right? So if I make dx is subject of squeezing it in here, I'll get dx is equal to du on cos x. So when I make a substitution, I'll get the integral of u to the 5 dot cos x by dx on cos x. What will happen? Cos x will cancel, right? And now, sorry, this is du, right? And now we can integrate u to the 5 dot du. That'll be u to the 6 over 6 plus c. So the final answer is what? The final answer is 1/6 of sine to the power of 6x plus c. That's okay? Anybody seen a general rule that come from this? Right? There's a general rule that can come from this, right? There's a general rule that comes from this. I'll give you one more, but what is general rule? Yeah. No, you will get a formula sheet. You have to do it. Right, you can't use the rule here, but try this last one, please. This last one, I'll give you 5 minutes and then we're going into application. 5 minutes break. All right, no break.
Yeah.
Yes, sir. That's what we're trying to split Saturday. If you get people out, I will let do it here. Right, try this, please. 3 sin x over 2 minus 3 cos x cubed. Right, use substitution and work it out, right? Yeah.
Yeah, I want to come to I'll know. Yeah, come to see you guys.
Ready? Go back in there. Yeah. Oh yeah. Now one there, please. Substitution again. Right, you're done. Done? Right, this one here. Watch here. There's no rule for us to do it, so we had to try a substitution and see. What would you let U equal to?
Science.
Part in the bracket, right? Every time you make a substitution, it generally the part in the bracket, right? Right, so try substitution and see what you get. Finish already now?
Substitution.
What? All right, so what will you get here? Right, so watch this here. How do we differentiate this? I've seen a little mistake with this. The differential of 2 is 0. The differential of cos is minus sine. Write back the minus 3 and write back here. So the differential cos is minus sine. Write back the minus 3 and write back here. So you'll get plus. You will get plus 3 sine x. Now, what that means is that dx is equal to du over 3 sine x. So I could come here now and make a substitution. 3 sine x dot, I'm replacing dx with this, and I will get du over 3 sine x all over 2 minus 3 is u, so that's u cubed. This will cancel with this, and you'll get the integral of 1 on u cubed dot du. Please don't do like somebody in the back of the class and try to. Why do you call your name? Right? Right? Don't introduce u squared here and u squared here. You can't introduce variables. Okay? Constants you could, but not variables, right? And all you're only using ln when you bring up the power and you get minus 1. That's the only time you really use ln. Okay? Anyway, right? Or the differential of the numerator is the differential of the denominator of the numerator. Right. When you reach here, you will get u to the minus 3, which is minus 3 plus 1 over that plus c. So your final answer is minus a half by u. Are you okay with that? Right? So what I did here? Take up, right? And I integrate this minus 3 plus 1 over minus 2 plus. Right? Take a 5 minutes and then we're gonna take a look at the differential equation. Yeah? Come on.
One over, no. 1 over 2 by.
Yeah, if you want to.
1, 2.
Right? Take a 5 minutes and then we're gonna take a look at the differential equation, right? 5 minutes of starting, huh? Huh? So all I did here, that was the integral of. So add 1 to the power, divide by 2. Minus 3 plus 1 is minus 3. Normal integration. I'm gonna put- Yes, he did. That's fully do document. Online, you start back in 5 minutes, right? I want to start back. I want to restart. Right? This is just one of the applications, right? Right? This is just one of the applications that we're going to look at. Right? Next week we'll finish up with the area and the goal, right? All right. So we're looking at differential equations, right? Right. So there are two types, right? There are two types of differential equations that we are going to look at. Right? In your exam, you'll really be focusing on first order, not really second order, right? How you identify the order is by the highest differential. So if I give you something like this, dy dx, or like dy dx is equal to some function, let's say 3x plus 1, that's a first order, right? The highest differential is 1. But if I give you something looking like this, where the highest differential is 2, equal to 0, let's say, right? This is second order. Okay? Right? But you could already kind of solve these things already, yeah? But we are going to focus mainly on first order, right? I just want to give you a quick example on how you would do something like this, right? So, how you identify a first order? The highest differential is just first differential, dy dx. How would it identify a second order? Highest differential is second differential, okay? So, let's just talk through this example while I'm coming up. Says that, suppose I gave you dy dx is 5x. Can you solve for y? Can you solve for y? Right? Technically, what you do, integrate here and integrate here. But here's what you're really doing. What you're really doing is you're moving the x on this side. And you're integrating dy, and you're integrating 5x with respect to x. That's technically what you're doing. So if you integrate 5x with respect to x, you'll get 5x on 2 plus c. That's okay? But if you integrate 1 with respect to y, what you'll get? Y. Right? This is the solution for this. Right? So if I ask you to solve a differential equation, that's what you're doing. You're okay with that? Right? And what we did here is that we use a technique. Right? We use a technique here called separation of a variable. Right? Right? A technique of separation of variables. Bring all the x on one side and we leave all the y's on one side. Okay? So generally, here's what you have. If you have dy dx is equal to f of x over g of y, right? Here's what separation of variables is, right? Take all the y's, bring it on this side. Take all the x, bring it on this side, and then integrate. That's okay? Right? So it will look something like this. It will look like dy, sorry. I bring in g of y here. And I bring in with respect to y. And I am corrected underneath here. When I separate the variables, I'll get g of y dot dy is equal to f of x dot dx, and then I can easily integrate here. Are you okay with that? Online, right? All I did is that if I give you a function like this, you bring the x on one side, you integrate it, bring whatever y's you have on this side, and you're good to go. Okay? So when I say solve a differential equation, what I'm really asking for is to make find back y. You remember in ATMAS? If I give you the gradient function in ATMAS, scalar, and ask you to find the equation, and you just integrate it. So technically, what you all have been doing was solving a first order differential equation. All right, Keshav. So the technique that we're going to do, right, and I will let Keshav come in this video, is we're going to apply this here, separation of variables. Right, Keshav, you are blue or red, man? Huh? Come on. Right? As I said, we're not focusing too much on second order. But if you had to solve a second order, any ideas? What you would do? Any ideas? Sophia? If you had to solve a second order, what you'll do? Forget that dy part. Suppose I ask you to solve this. d2y dx squared is equal to 5x. Yes. Integrate, get dy dx, integrate again, get y. Very good. So you would integrate this twice. So at your unit 1 level, that's all they will give you. In unit 2 though, right, there's a way to solve these. Let's do it again. Let's solve second order. No. Unit 2. Copy down and let's try one now. So in exams, they will not give you this. They will give you a long passage and you have to come up with the equation to solve. Right? So you have to learn to formulate it. Some of you all may have done that for SBA as well. Okay, good. हाँ भाई I hope not. All right, let's get ready to solve that, right? Let's see if we can solve this first order here. What does dy mean again? Gradient function, right? Not gradient function. Okay. Really. Oh yeah. Come on, ready? Right, we'll do number 1 together. Right? So let's see what you come up with. So what we'll do here, Shaq, we have a first order, we have X's and Y's. What you will do? Separate the variables. I like how you say that, Shaq. Separate the variables. What does that mean again? What does this mean? Separate the variables. Right, so I'll bring y cube here. And I'll bring dx on this side. Any questions online? Chelsea, are you okay? Are you okay with us? What's the next step, Prescott?
Sorry.
Integrate, right? Integrate. What's the integral? Excuse me. You're almost done, Pete. You shall excuse me. That's better than for like half an hour again. What's the integral of this? Pete. Pete? What's the integral of this? Y to the power 4 over 4. And here is what? X cube over 3. Do I have to write plus C here and plus C here? Just one, right? Tamara, are we done there? No, ma'am. Want to make y the subject. So we have to get rid of the 4 and the to the power of 4. Right? So multiply everything by 4. So you'll get y to the 4 is 4x cubed on 3 plus 4c, and then carry across the power of 4, and you'll get the fourth root. Right? Pardon me, sir. I multiply everything by 4. I select constant here. Sorry. Let's try our next one. Hello, okay, online there. Let me see. Garage, are there still? You getting through? Yeah. Right. So I'm going to ask you, of course, what topics you want to review on Sunday for those who come in, right? I can copy this pass online to us, so well, I can't make it. I'll see what I can do with it. I'll read to that class on that topic. Now that go about that. Yes, sir. Huh? Where? Yeah, we must learn physics or physics, not much so. Physics and math. Physics is and math. So I'll tell you, I'll write it down and I'll make it. Okay. All right. Try next one here from up, please. Number 2, solve. All right, number one here. Now it's Marquis. Hurry up now, boy. Double it up. Oh, yeah. Yes, yeah, yeah. We have 3 to do, and then we take a look at formulating one. It's more time to make y in the end. You gotta make y this up to 24. Integrate both sides and then make y this up to 34. Gosh, I'm distracting him now. Oh, yeah.
Sí, se tiene una ventaja.
Look at it. Try it real quick. All right, let's check out the first one. All right, all right. All right, so you'll bring the y's on this side, so that'll be 1 on y squared dot dy is equal to 8x cubed dot dx. When you integrate this, you're integrating y to the minus 2 dot dy. When you integrate this, you'll get 8x to the 4th on 4 plus c. This will give you y to the minus 1 over minus 1, 2x to the 4th plus c. Carry across the minus 1 if you want. You'll get 1 on y is equal to minus 2x to the 4th minus c. You want to make y the subject, so all we have to do is flip it over. So you'll get y is 1 over minus 2x to the 4th minus c. Right? Don't put the c on the outside, right? Right? This whole thing here is the entire function. Okay? This one here, what did you reach here? Selena? How about? You okay with this one? You sure? This one here is what now? You'll finish this one? All right. Oh yeah, give me a minute again. Yeah, but that one there too. Oh. But it's got 12. What do you want now? He knows it, right? Right? Ready again? How about? Target y squared, we divide them both sides by y squared, so with 1 over y squared. Oh yeah, got that? To the next. Yeah, that's fully the gate, right? Right, sorry. So what we're doing here? So you will get 1 over y dot dy is equal to x dot dx, right? 1 over y is when you integrate this, what you'll get. Right? And then we are getting rid of the ln. So when you move ln across the equal sign, we'll get e to the x squared on 2 plus c. But just watch this here for 1 minute, right? When you reach here, right? When you reach here, y is equal to e x squared on 2 plus c, right? What does plus mean? Plus mean that you're actually multiplying, right?
Yeah.
So I would have written it like this, right? That's okay? And e to c is really what? E to the c is really a what? Constant, right? Right? E to the c is really a constant, right? So instead of writing e to the c, what they do sometimes is they write e. Right? So they write A. So they say, well, where A is equal to e to the power c. So your final solution will look more like this. That's okay? Your final solution will look something like this. All right, and we have one more there to do. Wait, one there. So it's two of them. I let it come in twice.
I think it's 3-year-olds because I see everybody's supposed to be.
No, I let it come in one.
Oh, they're just.
I lost. I don't know what going on. Huh? I don't know what's going on. Last one. Last one here. Oh wait, we are on top. Last one there, all here. Try that, please. Oh, you win. It's gone. Amen. Thank God. All right. Huh? Right. Right. Slowly now, back here now. Right. Everybody okay with this? Watch, the reason I did this one is because this is the most popular one that I will see in the past papers, right? Don't leave your answer like this. Bring your answer back to this form, right? That's okay?
Why?
Right, because these are more general forms that you will see exponential equations in. I called e to the c e. Yeah, because it's a constant anyway, right? From here, the indice has a plus sign. Okay? All right. Right, so let's try this last one here, and I have one more to give you. Right, but what does this here mean? Ishana, since you don't know, what does this here mean? Anybody? Right? Yeah, what this saying, right? Our final answer will be v of t equal to something, right? Our final function will be that. What this saying is that when t is equal to 0, the v value is 1. The v value is 1. That's what they're saying, right? So when v is 1, t is 0. So for example here, if I gave you x is 5 and y is 1, can you solve for a?
Yeah.
Right? So that's the purpose of this. If I give you t is 0 and v is 1, you could go and solve for the constant. Right? So this now will allow us to find what we call a particular solution. This is a general solution. And when we get A, that's a particular solution. Tomorrow, you okay with those two words, general and particular? Right. So here, well done. Bring all the B's on one side, bring all the T's on one side. Pardon me. So what they're saying, sir, is after we solve this, right? After we solve this, we're going to have a constant, right? So to find the constant, if you write v is 1, sorry, when t is 0, v is 1, you'll be able to find the constant. Okay? Oh. So do the summing up, please. And then we have one slight question to do and we done. Flat. Yeah. Huh? How I can see these coordinate items here. Yeah. Right? So you're going to end up with 2 root b dv is equal to root t plus 1 dot dt. Integrate here, integrate here. I know it's looking a little bad with these square roots, but Kalina will help us figure it out, right? So I put in a half here, and I put in a half here. What's the integral of this? Is it a u or an L term? Topic u. 2v3, right? 3 on 2 over 3 on 2, right? Equal to, here's what? 3 on 2 over plus integral of 1 is t plus c. All right. If you want, you can find for c and then make v the subject. It's up to you. Okay. But let's see if we can make it look a little bit nicer. Flip up the 2. I'll get 4v 3 on 2 all over 3 all over 3 is equal to 2/3 t to the 3 on 2 plus t plus c. Now, I think catch him yesterday. Right? Everybody okay with that? Right? But before we make b the subject, you wanna do right? Before I make b the subject, I am going to find for c using this. When v is equal to 1, t is 0. So I'm gonna substitute t is 0, and I will get c is what? What would I get? Right? I will get 4 over 3 by 1 to the 3 on 2 is 0 plus 0 plus c. So that means c is 4 on 3. So I get in 4 on 3, b to the 3 on 2 is equal to 2/3. Right? When you reach here, you can multiply every single thing by 4 on 3. You will get b to the 3 on 2 is equal to 8 over 9, t to the 3 on 2, 4 over 3 to t plus 16 on 9. Right? And then you can bring across this, right? And when math will be plenty, it'll be like about an 8 mark. Yeah. Right? So when you finish, you'll get the cube root of right, all squared. Right? This is called, right? This is not a general solution. This is called a particular solution, because this value for c could change if I give you different t and v values. Everybody okay with that? Anybody confused? All right, so we just have one to do. Right? In words. One where we formulate the whole thing. Was that clear? I plug in 1, so I get 1, 0, 0 plus c. Huh? Oh, sorry. You can also what shape? If you see the night exam, you will see it. It's come all the time. All right. Let's try this one here now. Last one on the done. Last thing, this is 2019 or 2017 or 2018 or 2021. One of them. All right, value. Sorry? Oh, shucks, by 3 and 4. Oh, sorry. Huh? Sorry. I'm supposed to multiply by 3 and 4. Right, online I multiply by the wrong thing, right? Samara tell me to multiply by 4 and 3, but it was really 3 and 4. Samara, I can't believe that. I cannot believe you multiply by the wrong thing. If I come there and show you, it didn't reach there. All right, last one, are we done? Last one, are we done? All I really want to see is the formulated. This is exactly number 6.
I walk along you that way talking about
Yeah, you. That's so true.
Oh yeah, cut on the equation part. Right, it's 2019 thing, right? I'll check on here. You have to create a differential equation from that information. Yeah. What does slope mean? Gradient, which is dy dx, right? So the slope of a tangent is equal to the product of the x and the reciprocal of the y. Create an equation and solve it fast. Fast. No, you gotta write that. It's right down. Well, the EM might be wrong, but it's somewhere around there. Hurry up, we have 1 minute again. Right, Esther gonna help us formulate it. So Esther, what they said that the slope of the tangent is equal to the product of the x and the reciprocal of the y. What does slope mean again? So dy dx is equal to what? Product of the Andy? So, how to write up? Push up. You cannot see that thing. Right. Reciprocality Y means what? 1 on Y. That's it? That's it? That's part 1 for 5 marks. Sorry, no, you gotta solve it, you gotta solve it. That's the first part, that's 2 marks. Alright, so solve that part, dy dx is equal to x on y. And then separate the variables and solve it. You'll get y dy is equal to x dx. Right, so you'll end up with y squared on 2 is equal to x squared on 2 plus c. Everybody okay with that? When you multiply everything by 2, you'll get y squared is equal to x squared plus 2c. Right, and then you can square it if you want. Everybody okay with that? So what we're trying to build up is to handle things like this properly. All right. Next day we'll do area and volume, right? And then that's it for my. Well, time up and then pack up already. But yeah, we'll find out the last one. Huh? Here's 4. And anybody get 4 on 9?
Yeah, you have to.
Anybody get PS4? Alright, 9. Alright, Colin, that's it there.
Seems Sunday. Alright. Shit, we'll Friday.